Hey everyone, and welcome back. In today's video, we are exploring the secure software defined wide area networking or SD-WAN, a type of networking technology that uses SDN principles to manage, optimize the performance of wide area networks, the WANs. Let's start this with a quick coverage about the issues for legacy WAN networks to adapt to the outgrowing needs of the applications. If you go back few years and think, all the apps used to be hosted in the customer's data center, which should have been secured very well with a private and MPLS connection and also a big next generation firewall. But the security perimeter is changing as most of the applications have started to move towards cloud. The workers access the applications from laptops and phones, from their homes, hotels, anywhere. So now it is mandatory that the security needs to follow them as well. From a remote worker's perspective, irrespective of his current location, he needs to backhaul to the data center to securely connect with the corporate applications, whether they are hosted on-prem or on the cloud, right? This is what is happening in today's traditional WAN. It would have been much easier if they can access the SaaS-based applications directly with all required security, right? Even from a branch location, if you must always backhaul to a data center location to securely access the cloud-hosted corporate applications, just because you have built your secure internet exit only in DC, then we are introducing a lot of slow, unpredictable performance issues in your own network, right? As the apps move more and more towards cloud, it's going to be more and more troublesome. With the legacy approach of managing every component individually, even if you deploy a separate security perimeter in every branches, it is going to introduce you to other issues like inconsistent security policies, management overhead, and obviously increasing the cost heavily, right? Also, when we backhaul all the branches to a DC using MPLS connectivities, the same also increases the cost to the organization. The key challenges which are driving the organization towards the SD-WAN are increased demand for cloud applications. Think of days where we have Exchange servers running in your data center, right? Those days are long. All core business applications are available as a SaaS offering by different OEMs now, right? So to keep up with the application requirements and meet expected performance, the current WAN approach will be a definite setback, like the legacy WAN approach. Next, about how simple your current WAN network is. Is it simple? Do you think so? Not at all, right? There will be a huge design planning investment done even to implement the WAN network. There will be multiple routing protocols with a lot of tweakings and a lot of touch points as well, right? And when you want to achieve active load sharing or load balancing in your WAN network, it is not a simple task as well. You must again do a lot of engineering still to achieve an ineffective load sharing, right? That is only a certain level you can achieve. Another challenge is the number of equipments you need in every branch to achieve different functionalities. Say you need a separate router for routing functions, firewall for a security, a WAN optimizer maybe as well, right? Think about the overhead this adds, starting from evaluating this many different components from different vendors separately and bringing in separate technical people, right, for each of them who must understand how the other component are implemented in the network as well, right? And it's tough to produce a best fit network. Finally, when all are implemented, it is also not going to be an easy day-to job. There is heavy lifting expected there as well for the operations team. And as we discussed, when you have too many devices which needs to be managed, configured separately, it becomes a tedious job as well. Finally, all these will add up to high infrastructure and connectivity cost as well. To sum it up, today's WAN approach is definitely not built for the cloud era. Most of the networks out there are network driven, right? Meaning they don't respond well based on applications need. To put it simply, they cannot understand the applications language, right? All they understand is IP, routing, etc. With this, you cannot guarantee your application users to provide a necessary quality of experience, and it is complex to achieve savings and an infra which can respond to your business needs. Now let's look at the new ways in which we can define the WAN with use of any of the SD-WAN products out there in the market. What does SD-WAN delivers? Securely connect all enterprise sites and remote users. Technically, just turn up the device and establish communication with the orchestrator. They should be able to fetch the details about other sites in the network and the IPsec parameters using with which they will form secure tunnels, right? They just form everything automatically. No manual intervention needed. Right? Then SD-WAN can ensure better user experience, traffic conditioning, WAN cost reduction. Also, zero-touch provisioning is a key feature in SD-WAN. So, spin-up of new enterprise sites will happen in minutes. Right? We can also apply unified enterprise security policies across an enterprise throughout an enterprise. Next important thing is templatization. Say, take for example, you have total 100 sites. Out of that, there is total 10 designs where 10 sites are designed. Right? What we can do is create 10 templates only, right? One per design. So the sites of same design will be added into the same template, right? To get into a little bit more detail, a template will have a common variables and parameters defined. So when sites of same design are attached to the same template, they will be probed for values. Say a classic example is you do a basic program to find sum of a plus b. When you run the program, the compiler will ask you the value of a and b, right? So it can add and give you the result. So the templates, while getting binded with a specific site, they will ask values for all the variables configured. So it will compile a final configuration along with the global parameter or values which are already available, and this final configuration will be pushed to the edge location. Next, segmentation. Another big thing you would hear me saying big things a lot of time, just because SD-WAN have made life simple by achieving complex thing in WAN networking almost automatically for you, right? Anyway, segmentation is nothing but example, you have 2 or 3 business units in your organization who you don't want any communication between at all, right? You can put them into separate segments in your SD-WAN. Or another example is when you have data and voice. Data needs to be hub and spoke only, as your data applications are hosted in DC. But the other side, voice related applications need to be full mesh. As you know, for obvious reasons, voice needs to be full mesh. In this case, we can put data traffic in one segment, defining that specific segment, segment to be hub and spoke. And in same way, put the voice traffic in another segment, defining that to be full mesh. Right? There are certain functionalities some of the SD-WAN vendor will support for brownfield deployments. Say leaking routes between the overlay and underlay traditional routing. These kind of inbuilt features in SD-WAN will make the migration period from legacy to SD-WAN very smooth, right? And finally, this all in turn will show up as a reduction in the total cost to the enterprise, right? For managing the WAN, managing, configuring, or designing the WAN in every layer, right? Which is the ultimate defining factor, right? Let us quickly walk through some basic use cases of SD-WAN. Before we start discussing on the use cases, a typical SD-WAN solution will have an orchestration layer which will define how the whole SD-WAN enabled network should function. Also, the same will continuously monitor, report, and track the performance of the overlay as well. This component is mostly the management or the control plane only. They don't participate in the data plane at all. The other side is the SD-WAN edge routers, which sits in the DC, DR, or in headquarters or branch locations. Right? These are the components which carry the data traffic between these locations securely and as per the policies defined by the orchestration layer. The diagram you see on the screen is a typical SD-WAN architecture with an orchestrator and SD-WAN routers deployed in on-prem DC, headquarters, and branches. Also, as you see, there is virtual instances of the same SD-WAN devices created in the cloud infra as well. Right? You will also see the secure access server, which is mostly a cloud-based service enabling secure service edge for the remote users of the organization, right? Actually, if you take only SD-WAN, this SSE, right, secure service edge, mostly won't be part of the solution. This gets added when an organization tries to adapt to a more advanced and wider solution, which is the SASE. For people who are trying to understand what is a SASE, you can in general think about SASE as a combination of both SD-WAN and SSE. Now first we can build automatic secure channels between the on-prem cloud DCs, headquarters, branches, using all available transport mediums, right? In this example, it will be via both in MPLS and internet together, right? It's a hybrid network. And through these tunnels, we can securely transfer data between headquarters, branches, and DC locations. Then, for instance, we can also locally break out from the headquarters and branch locations to SaaS applications or entertainment or any other internet sites as needed, right? The point to note here is when you break out, you are not just breaking out without security, right? We can enable next-gen firewall or UTM functionalities as needed in those branch locations. Yes, SD-WAN routers itself, right? You don't need a separate box. If you see this slide, we have tunnels between all the SD-WAN routers. For a minute, let's see from the headquarters SD-WAN routers perspective, right, from its shoes. Via these secure tunnels, they continuously probe the on-prem DC and all other branch locations to identify loss, latency, and other SLA parameters. Not only to the on-prem DCs, but the probes are also exchanged with the virtual cloud hosted DCs as well, right? The one you see in AWS Azure as per the slide. All these details are continuously monitored and captured and updated in all the SD-WAN routers, right? For our case, we are just discussing from a headquarters perspective, but every box does this from its own perspective, right, to all other sites. Say, as you see here, in this table, from headquarters to DC, the latency is now around 2%, to AWS is 0, etc. Right? And in my slide, it will look like a constant, but it will be dynamically changing. So as the latency becomes bad, so you will see that the value keeps changing, right? It is dynamic. Right? Now we understand that the SLAs are being continuously monitored between the sites. Where do we utilize it, right? When you do something, what is the use for that? One, we plot statistics and reports in the analytics, right? So we can look back at the performance of the overlay at any point in time when we need it, right? Other, we use this to define the application aware policies. Say in our case, if you see the presentation, right, we are creating two rules in the policy. First one says use the Finacle application via the tunnel we have through MPLS, and failover to the internet tunnel only when MPLS path is down, right? Or it goes beyond the configured threshold. Same way, O365 application will locally break out via the internet path available in the branch itself, and when the internet is down or it's beyond the configured configured threshold, right, it will move to the DC over the MPLS tunnel and then break out from the data center internally. Right, that's how we are writing the policy. Right, when we say we write the policy, it's like we configure it, right, as per the vendor. They have their own ways in which we define the policies. Right, it will not be definitely like ChatGPT where you just type, right. Until at least today, we do have to configure it in the vendor specific way. Just a quick representation. The MPLS link, as you see, have went down or went beyond the configured threshold, right? We can assume. You can visualize that Finacle application moved via internet tunnel, right? Finacle, for people who are not used to it, it's an application, right, which the BFSI customers uses in general. So we just took it for example here. Now, when the MPLS link comes back up or becomes compliant, the same will move back to the MPLS path. But no, once you configure this policy, there is no manual intervention needed at all, right? When the issue arises, everything is automated, and when the issue resolves, it falls back automatically as well. Now in case when the internet link in headquarters is down, right, or out of compliance, then the O365 traffic which was breaking out locally, right, via the direct internet path available in the headquarters, will go now via the MPLS tunnel, via the overlay, right, in the MPLS transport to the data center, and then will break out from there. In general, SD-WAN does have a variety of features available, starting with in-depth security, as we discussed already, right? Next-gen firewall, antivirus, IPS, IDS, etc. Right? Plus, you can also do QoS, TCP optimization, policy-based forwarding, right? Routing, switching, right? The traditional, you have to be backward compatible, right? When you have something in the WAN layer, there will be requirements where you have to form BGP, OSPF, etc. with say for example a core switch in a data center, right? So you should be capable of doing that. So most of the SD-WAN vendors are backward compatible as well, right? And technically, you have to note, you have to worry mostly about the LAN side only. The WAN side is completely automated, as we already discussed, right? Even though the specific vendors have their own protocols, right, which some vendors I see have used BGP in their backbone and somehow came up with their own protocols, right? Ultimately, the WAN is completely automated by them. So all we have to do, control the WAN, right? When you want to control the WAN backbone, you use policies. Only in the LAN side, most probably these routing things will come into picture. And what about switching? Switching is like a smaller branch where you have only 2 or 3 users. So you can configure a few of the ports of your router as switch ports. Just bring them up, right? You don't need a separate switch, right? Or some other use cases as well. But an SD-WAN router will have the capability also to run switch port, right, and create SVIs. It will have the capability in the LAN side. And also other advanced options as well are available, right? Forward error correction, deduplication, right? But note, the feature sets will always differ, between every different vendors, right? They will have their own feature sets, and also they will have their own unique selling points. Now let's look at some of the deployment models of SD-WAN in large and small sites. On the left side, you can see that we have stacked up network and security components, starting with WAN router, WAN optimizer, next-gen firewall, and a LAN device as well, right? This approach was okay until we had no other choice, right? And we all know that this is tough to manage and a costly one, right, as we already discussed. Fast forward in recent years, as the WAN networks evolved, right, to SD-WAN, right, the important thing they produced is security functionalities, switching and WAN optimization, etc., even Wi-Fi, right, in the same hardware. So instead of stacking up devices, we can have a single SD-WAN box deployed in a branch, which can deliver all these functionalities needed for us, right? And obviously, as we discussed, the other things comes into picture. Everything can be temporalized, including security functionalities, Wi-Fi or enabling Wi-Fi, the SSID creations, everything can be temporalized. And as you see, there are different types of transport combinations which we can have, right? But we will be able to use all available transports, irrespective, right? It can be a MPLS internet combination or internet 4G combination. We'll be able to use both, still achieve load sharing, right, between them. First, if you see, for example, type 1 is where we have an ILL and the MPLS fiber links, which we can terminate on the SD-WAN, utilizing for load sharing. MPLS plus MPLS combination, internet plus internet combination, all combinations will work technically, right? We can also have LTE based internet transports built in our network. Depending on the requirement, this LTE based transport path can be utilized as active along with the other link available, or as a backup solution as well. Just come up only when some of the SD-WAN vendors directly have options where you can configure that as a last resort, so that it comes up as a final option only, right? It comes up and start utilizing the quota of data, right, available only when all the other available paths are gone, right? Finally, most of the SD-WAN vendors have equipped their SD-WAN routers with Wi-Fi functionalities, right, as I told you. In a scenario where we have hardware and link redundancy both required, we can say connect the first transport in the SD-WAN router 1 and the second transport in the SD-WAN router 2 physically, but still achieve link load sharing. We can do that, right? SD-WAN router have the capability to extend transport from one SD-WAN router in a HA pair to the other one. Right? In our case, even though the internet transport is physically terminated on the SD-WAN router 1, the SD-WAN router 2 will also know about this transport and will believe that it is available via the interconnect link. It just believes that it have internet as well. Simple, right? And the same will happen vice versa for the MPLS transport as well. Let's have a quick look at Calculus as an organization, our global experience in deploying SD-WAN, SSE, right, together as well. We are working with a pharma and biotech firm whose objective are update their WAN technologies with SASE, which is basically SD-WAN plus secure services edge, right? Our team did this, right? They needed HA in both hardware and link level, application awareness and traffic prioritization, hybrid network with different combinations of transport mediums, as we discussed, right? They needed that hybrid network, DIA in branches for local breakout, and obviously security when we are locally breaking out, right? That is a key thing. Separate segment for their corporate users from every other system, right? They needed a complete segregation for their corporate users. Right. End-to-end, that also is needed. You have to note that point. End-to-end, we give segmentation, not only in a specific branch level. When the traffic hits the branch, until the DC router, DC SD-WAN router hands over the traffic to a core switch, maybe in DC, until from start to the end throughout the WAN layer, it will be segmented, completely segmented, right? And all security features, obviously, while as we discussed, while breaking out to the internet. Also, site-to-site VPN with third-party partners. Right? These are their objectives. Some of the challenges the customer have highlighted to us, where their migration schedule was tight and they needed a quick implementation or branch rollout. Right? They don't want to spend more time to migrate these legacy to SD-WAN. Right? They had an important application called Empower, which had an issue to support WAN optimization, so are not able to achieve good application performance from branch locations. Right. What we have done, we have enabled secure SD-WAN in DC locations and branches and SSE for their remote clients. We used a specific vendor, which we don't want to declare in this video. Also, the branch rollout have been completely automated, so there is very minimal downtime required, as well as the overall branch onboarding timing was very, very low, right? And the onboarding is not error prone, as everything were already templatized in the orchestrator. For the Empower application, whose performance was a concern, we were able to achieve a great performance by doing TCP acceleration and prioritization of transport based on SLA, etc. With the enhanced analytics capabilities of SD-WAN solution, the customer was able to get a detailed analysis about their WAN network. Next, there was another deal, dental customer who had similar requirements, but in addition, they wanted to run the SD-WAN on a white box, right, instead of vendor-specific hardware. Right, this gives them a lot of flexibility, right. Also, they wanted immediate traffic switching between the links if any one of the links goes down or out of compliance. Plus, they need a segmentation for data, voice, and guest traffic in their network as well. Today, the customer has built static IPsec tunnels, right, from their branches towards DC. And when they want to build secure branch-to-branch communication, it is a tedious job, as they must keep adding new tunnels, right. They are not able to utilize the LTE or 4G SIMs as transport effectively. Understanding all these challenges and their objectives, what we have delivered to them, we have deployed a SD-WAN solution using a white box vendor for all their branch locations. Started to utilize all available transports in the branch location for load sharing. And we were also able to use the LTE 4G based solutions as transport. and also control the traffic flow via them as per the policies. Finally, we have also enabled full stack security functionalities in the edge locations while breaking out to the internet. To wrap it up, SD-WAN will be ruling the market for coming years, and a lot of vendors out there are heavily investing on the same. Also, customers on the other side are very much interested in modernizing their networks, right? To be on top of the technology adoption table between their competitors as well. That's a wrap for today. If you found this video helpful, don't forget to like, share and subscribe for more content on latest technologies and networking solution talks, right? Thanks for watching, and see you in the next one.